Welcome to the lecture Digital 3D Documentations in Archaeology. Digital Photography as Basic Tool, second part. Here we see an overview of the topics we want to discuss in this lecture. This should help us later to find the individual topics more quickly. Now let's discuss positioning and illumination of finding photographs. It is worthwhile to think about the positioning and illumination of the finds in advance and to invest some time with test shots for a functioning and adequate setup. The purchase and use of additional technology, such as tripods and light sources, should also be considered. The archaeological light, by which is meant the key light in a lighting setup, always shines from the upper left onto the find object. Here, some basic principles for a good illumination recommendation can be taken from 3 or 4-point lighting. Find objects should usually be photographed to fill the format. Since the find images can be combined better later and embedded in publications without a background of higher quality, care should be taken to use a monochrome background, if possible, matte white or matte black. Most people have a good and sufficient recording possibility for high-quality finds. Images with their smartphone or a digital single-lens reflex camera. We will examine different shooting scenarios outdoors and under reproducible, optimal lighting and shooting conditions and compare the results of different devices with each other. Later, when it comes to taking special detail or macro shots in a light tent, the topics of sufficient lighting and higher quality cameras take on greater importance. 3-point lighting is a classic lighting setup that is often used, for example, for film shoots, interviews, or portraits. Spotlights are preferably used for the 3 dominant light sources. The aim is to illuminate the subject in such a way that each level is illuminated with a different intensity. The key light is the brightest light in a scene and indicates the dominant angle of illumination. It is the natural light. The fill light is used in addition to the key light to brighten the dark areas. The backlight is used to separate the illuminated object from the background. It illuminates the object from behind and creates a bright border that serves as an edge between the object and the background. The lighting setup can be extended to a 4-point lighting, in which the background is additionally illuminated with a background light. If we apply this concept to finds photography, as shown on the right, then we have a working setup that is appropriate for archaeological photography. This knowledge can be useful to us in choosing the positioning of the subject and camera and the illumination in the field when we find already given light sources. In photography, we distinguish between hard and soft light. This designation is directly derived from the shadow image that is created. These and other topics are discussed in my book. A point light source, such as the sun, produces a clear hard shadow, while multiple point light sources, produced by a diffuse light pattern, produce a soft shadow by superimposing the shadows. Later we will deal with the topic of white balance a bit more intensively. Here a few examples should show which drastic effects of different color perception can arise in the pictures with and without white balance. The automatic white balance can be set directly in some cameras, or it can be applied afterwards using software. The images shown in the outer area show photos of found objects without automatic white balance, and on the bottom right, a photo with automatic white balance. For coins, which are usually very flat, there is a special way of capturing the face and value side, or obverse and reverse, with a flatbed scanner. However, the third dimension of the coins is completely lost with this method. It is important to make sure that the highest possible DPI number is set during scanning. With this recording variant, we have the great advantage of being able to digitize many coins in a very short time under very good lighting conditions. Due to the existing white background, the coins can be separated very well later on. The disadvantage, however, is that we only get 2 possible images with the image and value side, which means that the 3D structure cannot be captured. Also, the shadow image is very unfavorable here. We first have to experiment to know the correct position of the coins in the scanner. After all, the goal is to perceive the main light source in the upper left corner. Using a scanner to photograph coins for publications in a scientific context is not the norm. In order to create high-resolution photos, a number of conditions are imposed on the lighting, camera setup, and subsequent software post-processing. Alternatively, coins can be photographed on an acrylic plate using a digital single-lens reflex camera and a special lighting setup with a macro lens. Let's first stay with the topic of coins as a concrete example of a find and see what requirements we have for daylight as a simple lighting setup and how this can be implemented. For this, we need 3 glass plates or transparent plastic plates and a white sheet of paper. Now we put a white sheet of paper on a glass plate or place it on a glass table. This gives us a simple alternative for a translucent ground that also gets some illumination from below due to daylight. To further reduce the shadow of the coin, we take another glass sheet and place it on the white sheet. In the middle, we now place the coin. We now turn the setup so that the daylight shines on the coin as a key light from the upper left. By using a third glass plate, we can redirect the daylight as fill light and use it from the lower right to brighten the coin. When taking the photo, we now zoom in on the coin and, if possible, select the macro mode of the camera. We now focus on the coin in such a way that the entire coin is in focus. For a few finds, this is certainly a very good option. Unfortunately, the setup is not so good in terms of reproducibility of the lighting setup, so that different photo sessions can lead to significantly different results. If multiple specimens are then juxtaposed, it can be distracting and unprofessional. A more professional setup can be realized, for example, in a light tent, a tripod, and different light sources, as shown on the left. Here we can force the light characteristic of outside light sources as diffuse. With a small investment of just under €50 in a light tent, for which backgrounds in white and black are available, we already have good equipment. For later photographs, which are also suitable for photogrammetry and videogrammetry, an automatic turntable, which can be purchased for less than €20, can be purchased. On the right, you can see such a turntable which rotates an object steplessly. With an adjusted camera angle, high-quality images can be produced that are suitable for detailed 3D reconstruction. Such a setup also has the advantage of reproducibility. Images can be easily compared side by side. In a light tent, we also have the possibility to vary the background with the same lighting setup. We should ask here, why is it necessary to pay attention to diffuse light when taking pictures for 3D reconstructions? The rule of taking images in diffuse light applies especially to photogrammetric images with the goal of 3D reconstruction. Since shadows baked into the texture, so-called fake shadows, can be very disturbing in later representations of 3D models. On the left, we see an example where, in the result of the 3D reconstruction, strong light sources produce strong shadows. In this example, the scene was captured with light coming from the left side. In the resulting 3D model, the shadows are already baked into the texture, analogous to fake shadows. On the right side, we see a subsequent new lighting of the scene, in this case from behind. The result looks flawed. The competing shadow gradients are irritating. When we're outdoors, we usually can't choose the weather for shooting. Here we are happy when dry and preferably wind-free conditions prevail. In close-up and also macro photogrammetry, where we can take and reconstruct smaller objects under laboratory conditions, we have the opportunity to artificially preset the lighting setup. Let's now look at a complete reconstruction result from the exposure to the model, which was systematically taken with the presented setup consisting of light tent and turntable. 3 acquisition cycles were performed, in which the object was captured from different perspectives, each with 25 photos taken with a Sony Alpha camera. Below, on the left, we see the 3 rotations in pose estimation and the result of the 3D reconstruction in reality capture. Here we see a few surrounding artifacts in the outer areas, but they can be easily removed in the program. At the top right, we see a few impressions of the fully textured 3D model. Below is the untextured mesh on the left and the DSM of the front and back side. On the back, the Buddhist mantra in Sanskrit is clearly visible. Now let's move on to capturing photos digitally. A very big advantage of digital photography is instant image delivery and the associated digital image processing. However, digital image processing has its limitations. Image and photo processing programs can improve photos through numerous methods, but from a bad photo with unfavorable lighting or a poor shooting setup, we usually cannot derive good images. Nevertheless, in the following short sections, we will talk about a few aspects of digital image processing. Let's move on to another important question in this context. Why is the correction of camera lens distortion so important? Generally, the camera lens leads to an optical distortion of the image. In the case of find or terrain photography, it often does not play a major role and is usually neglected. However, if the goal of the camera images is to measure content, as is necessary in photogrammetry, for example, then this optical distortion can have a significant influence on the result. Here we see an example from a documentation campaign in Iceland from 2015, where a GoPro Hero was used. On the left, you can see the result with the original recordings. Due to the presence of the fisheye lens, a curvature of the overall model can be seen. However, when viewed from above, this curvature is barely noticeable. The example in the middle shows the result with distortion correction of the images. Already in the upper image, the plane of flight is very clearly visible. However, the distortion correction of the camera images is a very sensitive step where great care is required. Wrong parameters can very easily lead to completely incorrect results, as the example on the right clearly shows. To perform distortion correction, we need to measure the lens properties. We often speak here of the so-called intrinsic camera parameters. To determine the parameters, we need a regular pattern, for example a chessboard pattern, and place it in the plane. The program now determines the interior corner points and calculates which correction is necessary so that these corner points lie again with regular distances on parallel lines. With OpenCV, only a short program is needed to determine the intrinsic camera parameters. The method implemented in OpenCV is due to Zhang's article and Bugay's code. An executable implementation is available, for example, using the Java program JUndistortion. With a few simple steps and in a relatively short computation time, the parameters for a distortion correction can be determined and then the images can be corrected. A short explanation of the program and the application will be part of one of the practical assignments to this lecture. Whole books can be written about the field of image processing or the post-processing of photos. Here we just want to point out one of the numerous free programs, GIMP, which offers a very wide range of functions and can be very useful. Professional photographers usually take photos in RAW format and do without the automatic camera settings, which always entails post-processing of images. A good way to perform the white balance of a photo afterwards can be applied quickly with GIMP. Simply load the image and select the sub-item Automatic in the menu item colors and then perform white balance. On the top left we see GIMP, where we can apply the automatic white balance via the menu. Below we see that also different possibilities of contrast enhancement are offered. On the right we can see the original image above and the enhanced one with white balance below. The image sharpness enhancement can be applied, for example, via the menu items Filter, Enhance, Sharpen. A window opens that allows a few individual parameter settings. On the right, we can see the significant change from the original image using an example. After listening carefully to this lecture, Answering the following comprehension question should help you to summarize the most important statements again on your own. The practical task is to become familiar with photography and practically apply a few methods of improvement. Install the J-on-Distortion program. In this task, the program J-on-Distortion is to be tested. Now is the time to try out your own camera and correct the image data.